So, this is me doing this again for the third time. I messed up the calc in the first time at like 17 minutes into the video. And then the second one, I finished it completely, just about to upload it, and I forgot to press the mic button, so it was just me talk. Well, it was just, you couldn't even. Okay, what we're doing now is something called non-homogeneous second differentials. All right, so the last video was homogeneous, which meant it equaled 0. This video this non-homogeneous means it doesn't equal 0. So what we have is an equation that looks like this. Now I'm purposely using an equation very similar from the last video for a reason. Okay, I'm gonna just change my pen color to black. Alright, so x squared is what the equation equals, and this is the question. Okay, now the solution to this, okay, is y subprime of x plus y subprime of p. Y subprime px. Okay, lowercase p if you like. I don't care really. Whatever. Okay. Now, all right. This is two solutions. All right. Now the first part. All right, and this is why I'm using an example from the last video. You need to look at the last video to understand this. All right. This is very complex and it's long. This part here, we've already done in the last video. All right. This is what you do here is you take the equation, okay, but you take it as a homogeneous equation. So you take it only as if it equal to 0, and you solve it, okay. And we solved it to be ae minus 5x plus be 4x, I suppose it was. Okay. Just need to put the charger without breaking anything. Phone, activate light. Almost there. Who knows, maybe I can cut this out from the video. But let's be honest, I'm not that. Maybe if I have 100,000 subscribers, I'll start to edit the videos properly. Who knows? Okay. Let's go. So, as I was saying, the solution to a subprime c of x we already have from the last video. Okay. Now, you would have to do this for a completely different question, obviously. You'd have to do the whole thing, but I'm saving time here. Okay, now, the part that we're going to focus on in this video is this lovely thing here. Okay? I'm going to tackle it in the next video here. So, in the next slide. So our question is d over x plus dy dx 20y equals x squared. Okay, so what you need to understand, alright, is that this, okay, we'll call this the left hand side, and we'll call this part the right hand side. Okay, so what we need to see is that this left hand side reflects a quadratic. Okay, now you might have already noticed this. Quadratic being ax squared plus bx plus c. A and b are just numbers given to the to the variables. Okay, now if you look over here, there's no numbers here. All right, which means it's 1. Okay, now what we're going to do is we're going to say that y subprime p of x equals ax squared plus bx plus C. I'm just going to check if the mic is working. I think it is. Yeah, it is. Okay. Now, alright, so y subprime px equals ax squared plus bx plus c. Now I'm going to say, if I take this and I differentiate it once, okay, what I get is 2ax plus b. And if I take this and I differentiate it again, so it's a double differentiation, I get, that's x. I get 2a. Remember, this is the rule for differentiation is times and take. So the power of x here was 1. 1 times 2 is just 2. And you take 1 from the power, which makes this 0. X to the 0 or anything to the 0 is 1. 1 times 2a is 2a. Okay? Now, this part's important. This part's very important. Okay? And we're going to use this in the next slide. Alright, I'm just gonna, so I can just rewrite everything. Okay, so what we had, alright, was d, so this is 1 of dx squared plus 1 of dy dx minus 20y equals x squared. Now if you recall, what we said earlier was y of px is just ax squared plus bx plus c. We said if we differentiate this once, we get 2ax plus b, and if we differentiate this a second time, what we get is 2a. Okay? Alright, and we said we're calling this the left hand side of the equation and this the right hand side of the equation. Okay? Now, what I'm going to be doing, alright, is this is a second differentiation term, right? This is notation for second differentiation, alright? And so is this. So I'm going to replace d2y over dx squared with 2a. So what I'm going to get is 1 multiply 2a, okay? And now I'm going to do it the same with this, okay? So that's 1 times 2ax plus b. 2ax. Ooh, what did I do there? Rubber. Come on. Okay, and this is the one I'm using. So 2ax plus b, close the bracket, and if we add it and we get the last one. Well, this one is not a differential, which reflects this one over here, and what we get is minus 20. I'll rewrite that part here, it's a bit of a mess. What we get here is, I'll even take off the positive. What we get here is minus 20 bracket ax squared plus bx plus c. Okay, and all of this equals x squared. Alright, now I want you guys to see something. Okay, this right hand side, okay, also reflects a quadratic equation. Okay, now in the question it gave us x squared. Alright, so in a quadratic, having this format here, ax squared plus bx plus c, that format still stays the same on this right hand side. Okay, so this right hand side has just x squared, okay, meaning that there is 0 x and 0 for c. Okay, understandable? Now if you were given the right hand side as the number 6, for example, that means you have 0x squared and 0x. If you were given 6x, that means you have 0x squared and 0 as c. Okay, you have to. This is complex math here, so you gotta make sure